Running low-voltage cable through walls is permissible in many areas, provided it's installed correctly within a conduit or raceway. This setup allows for remote mounting of the transformer, negating the necessity for multiple transformers. Firstly, obtaining a permit is essential in most localities from the local building department before commencing any electrical work. Secondly, selecting the appropriate cable is crucial. Opt for CL2 or CL3 rated cable, specifically designed for in-wall applications. Thirdly, installing the cable within a conduit or raceway safeguards it against damage and moisture exposure. Fourthly, adhere to the manufacturer's instructions pertaining to the transformer. Typically, transformers mandate connecting the low-voltage cable to a designated terminal block. Fifthly, upon installation, rigorously test the system to ensure proper functionality. Should you feel uneasy about running low-voltage cable through walls independently, enlisting a qualified electrician is advisable. An alternative method for powering multiple lights within a room using a singular transformer involves employing a power distribution block. This apparatus facilitates connecting several low-voltage lights to a single transformer. Power distribution blocks are commonly positioned in a central location, such as a closet or attic, with the low-voltage cables extending to individual lights. There are several advantages of utilizing a power distribution block. Firstly, it offers reduced cost. Employing a power distribution block can economize expenses by obviating the requirement for multiple transformers. Secondly, it provides increased flexibility. Power distribution blocks enable effortless addition or removal of lights from the system without necessitating extensive rewiring. Thirdly, it enhances aesthetics. Power distribution blocks can be discreetly concealed within a closet or attic, thereby augmenting the room's overall visual appeal. If contemplating the incorporation of low-voltage lighting in your residence, consulting a qualified electrician is imperative to deliberate your options and ensure proper system installation. In the 2008 National Electrical Code, Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. These circuits are often used for low-voltage lighting systems. Section 725.3 provides general requirements for these circuits, including permitted and prohibited uses. Section 725.55 outlines wiring methods for Class 2 and Class 3 circuits, specifying requirements for cable types, support, and protection. Section 725.136 details the overcurrent protection requirements for Class 2 and Class 3 transformers and power supplies. For running low-voltage cable through walls, the NEC requires that the cable be suitable for the application and installed in a manner that protects it from physical damage. This often means using listed cables such as CL2 or CL3 cable and installing the cable in conduit or another approved raceway. The specific requirements for cable installations can be found in Chapter 3 of the NEC, which covers wiring methods and materials. For example, Article 300 provides general requirements for wiring methods, including requirements for support, protection, and grounding. Article 310 covers conductors for general wiring, including requirements for ampacity insulation and installation. In the context of remote mounting a transformer, the NEC addresses the installation requirements for transformers in Article 450. This article covers topics such as transformer location, ventilation, and overcurrent protection. Section 450.11 specifically addresses guarding transformers, requiring that they be protected from physical damage and unauthorized access. When using a power distribution block to power multiple lights from a single transformer, it is important to ensure that the block is properly rated for the load and installed in accordance with the manufacturer's instructions. The NEC also requires that all electrical equipment be listed and labeled, so be sure to use a power distribution block that is listed by a recognized testing laboratory. The ampacity of conductors must be sufficient for the load they will carry, as specified in NEC Table 310.15b16. Overcurrent protection devices, such as fuses or circuit breakers, must be selected to protect the conductors and equipment they supply, in accordance with NEC Section 240.4. Grounding and bonding are essential for electrical safety and must comply with NEC Article 250. This includes grounding the transformer enclosure and bonding all metal parts of the electrical system. Always consult the latest edition of the National Electrical Code or local amendments for specific requirements in your area. A qualified electrician can provide guidance on proper installation techniques and ensure that the system meets all applicable codes and standards. When working with low-voltage lighting systems, several key components and considerations are essential for ensuring safe and efficient operation. These include transformers, which convert high-voltage alternating current power to lower voltages suitable for lighting, wiring and cabling, which carry the low-voltage power to the lights, lighting fixtures, which house the light sources and provide illumination, and control devices, such as dimmers and switches, which allow for adjusting the brightness and turning the lights on and off. Transformers play a crucial role in low-voltage lighting systems, as they step down the voltage from the main power supply to the level required by the lights. These transformers come in various types, including magnetic and electronic transformers, each with its own advantages and disadvantages. Magnetic transformers are typically more robust and reliable, but can be larger and heavier. Electronic transformers are smaller and lighter, but may be more susceptible to voltage fluctuations and overheating. The selection of the appropriate transformer depends on the specific requirements of the lighting system, including the total wattage of the lights, the input voltage, and the desired output voltage. Wiring and cabling are essential for connecting the transformer to the lighting fixtures and control devices. Low-voltage cables must be appropriately sized to handle the current requirements of the lights, and they must be installed in accordance with local electrical codes and regulations. Common types of low-voltage cables include CL2 and CL3 rated cables, which are specifically designed for in-wall and in-ceiling installations. When running low-voltage cables through walls or ceilings, it is often necessary to use conduit or raceways to protect the cables from physical damage and ensure compliance with electrical codes. Lighting fixtures come in a wide variety of styles and designs, each with its own unique characteristics and applications. Low-voltage lighting fixtures typically use LED or halogen lamps, which are energy efficient and long-lasting. LED lamps are becoming increasingly popular due to their high efficiency, long lifespan, and ability to produce a wide range of colors. Halogen lamps, on the other hand, offer a warm, natural light that is often preferred for certain applications. When selecting lighting fixtures, it is important to consider the desired light output, color, temperature, and beam angle, as well as the overall style and design of the fixture. Control devices, such as dimmers and switches, allow for adjusting the brightness and turning the lights on and off. Dimmers are particularly useful for creating ambience and saving energy, as they allow for reducing the amount of light produced by the lamps. Low-voltage dimmers come in various types, including rotary dimmers, slide dimmers, and digital dimmers. The selection of the appropriate dimmer depends on the type of lamps being used and the desired level of control. When installing low-voltage lighting systems, it is essential to follow all applicable electrical codes and regulations, as well as the manufacturer's instructions for the various components. It is also important to ensure that the system is properly grounded to prevent electrical shocks and ensure safe operation. In addition to the basic components of a low-voltage lighting system, there are also several accessories and options that can be used to enhance the system's functionality and aesthetics. These include power distribution blocks, which allow for connecting multiple lights to a single transformer, wire connectors, which provide a secure and reliable connection between wires, and mounting hardware, which allows for installing the lights in various locations. Power distribution blocks are particularly useful for simplifying the wiring of low-voltage lighting systems, as they allow for connecting multiple lights to a single transformer without having to run separate wires for each light. Wire connectors are essential for creating secure and reliable connections between wires, and they come in various types, including wire nuts, push-in connectors, and crimp connectors. Mounting hardware is used to install the lights in various locations such as walls, ceilings, and under cabinets. When designing a low-voltage lighting system, it is important to consider the overall lighting needs of the space and the desired ambience. Low-voltage lighting can be used to create a variety of effects, such as task lighting, accent lighting, and ambient lighting. Task lighting is used to provide bright, focused light for specific tasks, such as reading or working. Accent lighting is used to highlight specific objects or features in a room, such as artwork or architectural details. Ambient lighting is used to provide a general level of illumination throughout the space. By carefully considering the lighting needs of the space and selecting the appropriate components and accessories, it is possible to create a low-voltage lighting system that is both functional and aesthetically pleasing. Always consult with a qualified electrician before installing any electrical wiring or equipment to ensure compliance with local electrical codes and regulations.